Hello everyone, the topic for this video is square and cube roots. Let's begin with square roots. So reminder, this is how square roots look. I know this wasn't the first time you guys have seen them. Again, often we leave, with a square root, we leave the index number or the little number there that goes there as a blank, but we can write it with a 2. So you don't need the 2 there, but you can put it there. Once again, the names, the little 2 there, the red number is the index number, and the 9, that's called the radicand. So the number underneath our radical sign is the radicand. Let's review the meaning. So what a square root really means is what number multiplied by itself equals the radicand. An example, or our example here, if I take square root of 9, what times itself equals 9? Well, 3 times 3 equals 9. Therefore, the square root of 9 is 3. Now we're going to look at some examples with square roots. We're going to determine the square root using the prime factor method. So you know you can use your calculator, but we're asked to try to find this with prime factors as well. The process isn't bad, so it's not a bad thing to learn this. Let's begin. So the first thing we're going to do is we're going to actually find the prime factors of 36, or whatever your radicand is. So in this case, it's 36. So let's say I go 12 times 3. So 12 times 3, I can then break 12 down further. I can go 4 times 3. And then I have to carry the 3 I already established. So the prime numbers that pop up, you carry along, and then you keep factoring down the non-prime. So 4 here, I can factor it further. 2 times 2, and then I carry those 3's down. Once they're all prime numbers, I'm done that part. Once you're done determining the prime factors, break or shuffle or reorganize, whatever you want to say, it into 2 equal groups. So I'm going to make 2 brackets here. I want to make 2 equal groups, so I can put a 2 in each bracket, and then I can put a 3 in each bracket. The value of the bracket is actually going to be the value of the square root. So I can see here that this is really 6 times 6. And if I go back to my definition, what number times itself equals the radicand? Well, 6 times 6 equals 36. So therefore, the square root of 36 is 6. You likely knew that one already, but it's good to learn the method on an easier question. So let's bump this up a little bit now. B, 576. With the prime factor method, takes a lot of, I guess, a little guesswork if you're not so good at your division rules. But if you're good at your division rules, that'll really help you out. One of the division rules I want to share with you is the rule for 9. If you add the digits of the number you're wondering about, and if it adds to a multiple of 9, then that number is divisible by 9. So if I look at this, 5 plus 7 plus 6, that equals 18. 18 is divisible by 9, so I know automatically 576 is divisible by 9. So 9 times 64 is 576, but I can keep going, breaking these down. 9 can turn into 3 times 3. 64, 8 times 8. Now, we're wanting to use a prime factor method, but if you ever get into a situation where you already have factors that can make 2 equal groups, you can stop short of the prime factors. So meaning, I can make my brackets right here. I can put a 3 in each bracket and an 8 in each bracket. I have my 2 equal groups, good enough. So determine the value now, that's going to be 24 and 24. So what number times itself equals 576? 24 is, so the square root of 576 is 24. Again, numbers are getting a little bit bigger. 1296. We want to find the prime factors. If you check that out, this adds up to a multiple of 9 as well. What is that? That's 18. So 9 will work. Then you have to maybe do some work to figure out 9 times what equals 1296. Well, it ends up being 144. Okay, so 9 is 3 times 3. 144. Most people will think of this, 12 times 12. Let's say you didn't realize you could have stopped there. Well, it's okay. You can keep going, and we'll show that it's still going to work out. Or maybe you pick different factors besides 12 times 12. So the 3's I carry, the 12, I can turn into 4 times 3. And then this 12, 4 times 3. Okay, I'm going to carry along my prime numbers. 4 is 2 times 2. Carry that prime. This 4 is 2 times 2. Carry along that prime. So now I've got a bunch of primes. Now I organize into 2 equal groups. So I can see I have 4 2s, so that means each bracket should get 2 2s. You can use exponents to save your writing, so I'll cross these out so I know I've dealt with them. And then it looks like I have 4 3s as well, so I can say times 3 squared, times 3 squared. That accounts for all my 3s. Now I need to determine the value of this bracket, so that's going to be 4 times 9. And seeing they're equal brackets, if you want to write squared here so you don't have to write 2 brackets out, that's fine. And 4 times 9 is 36, and then I got to remember my squared. So 36 times 36 equals 1296, meaning the square root of 1296 is 36. So it's the prime factor method, but if you if you find non-primes that can get you those 2 equal groups, you can stop there. Because if I look at this again, this could have been 3 times 12, 3 times 12, that is 36 again. So I could have stopped earlier if I would have recognized it. Sometimes you do, sometimes you don't. It'll work out regardless. All right, our final example. Same process. Take your number, start chipping away. We got to find the prime factors. A lot of numbers that add up to multiples of 9 here. So that adds up to 18 again. So 9 is a great number to try. 9 times 196. 9 is 3 times 3. 196. The numbers I found were 4 and 49. And again, that takes some trial and error. You just got to work at it. I'm moving really fast because I've worked these out before, just so I don't waste your time as much in this video. I don't want to have a bunch of dead time with me thinking. But getting back here, carry my prime numbers along. Keep breaking down the non-primes. 49, 7, and 7. So those are all primes, so I can make my 2 brackets. I have 2 2s, meaning each one will receive 1 2. I have 2 3s, so each one gets 1. I have 2 7s. All right, determine the value of that. So that's going to be 6 times 7, so 42. And then I'm just going to say squared. I don't feel like writing it out twice. So 42 times 42 equals 1,764, meaning the square root of that number is 42. So, quick summary for how we do this. Step 1, determine the prime factors of the radicand or the number in question. Step 2, organize the prime factors into 2 equal groups. Step 3, determine the value of the equal groups. This value is the square root of the radicand. Now let's focus on cube roots. So symbol, again, I'm sure you've seen it before. It's that normal, that same radical sign. Now notice the index number. It's changed to a 3. If it was a 4th root, that'd be a 4. A 5th root is a 5, and so on. So radicals have that very definite pattern. Same names, index, radicand. The meaning, what number multiplied by itself twice equals a radicand? So what that looks like is I pick a number, so 2 times itself twice. So 2 times 2 times 2. That equals 8. Therefore, the cube root of 8 is 2. Examples. Same process, everyone. Prime factors, now 3 equal groups, however. So, 216. If you add that up, it adds to 9. So I can use 9 again. 9 times 24. 9 can be then 3 times 3. 24, there's different ways you can do it. I went 6 and 4. Don't know why I went that way, I just did. You could have used 12 and 2, 8 and 3, whatever. It all works out in the end. So carry along my primes. 6 becomes 3 times 2. 4 becomes 2 times 2. Like I said, 3 equal groups. So I see there's 3 2s. So each bracket gets a 2. There are 3 3s. So each bracket gets a 3. Determine the value of that. That's going to be 6. And there's 3 of them, so I'm just going to write cubed. So 6 times 6 times 6 equals 216. Therefore, the cube root of 216 is 6. So again, same technique. It's just now 3 groups. 1,728. If I add that up, that adds to 18. 18 is a multiple of 9, so 9 times 192. 9 becomes 3 times 3. 192. You might have to play around with that for a while, but another divisibility rule. If I add these digits, 1 plus 9 plus 2, that adds up to 12. If a number is divisible by, if the sum of the digits is divisible by 3, then the original number, 192, is divisible by 3. So then 3 will work here. So 3, and it works out to be 3 times 64 is 192. Okay, so I carry along my primes. 64 is 8 times 8. 3 times 3. I'm carrying these primes along. 8 ends up being 4 times 2, but I'm feeling lazy, so I'm just going to write, I'm going to break that down too. It's going to be 2 times 2 times 2. And then I have another 8, so another 2 times 2 times 2. All right, so I have my 3 groups now, or I'm going to have to try to make them into 3 groups. I have a 3 in each group, because I see I have 3 3s. And again, you can use exponents to your advantage if you don't feel like writing everything out. If I count, I have 1, 2, 3, 4, 5, 6 2s, meaning each of these should get 2 2s. So I can go 2 squared, 2 squared, 2 squared. So 1, 2, 1, 2, 1, 2, all accounted for. Determine the value of the bracket. 3 times 4 is 12, and again, there's 3 of them. So we're saying 12 times 12 times 12 equals 1,728. Therefore, the cube root of 1,728 is 12. 2 more examples if you need it. It's a video, so you can stop now if you wish to. Same process, 2,744. Now, I know I might feel like I'm going pretty fast through here. Again, the reason why I have these questions worked out, because I don't want to have a lot of dead air as I think through things. Okay, so 2,744. I had to play with that number for a little bit. I came up with 4 times 686. So if you need your calculator to play some kind of, guess and check, that happens sometimes. 4 becomes 2 times 2. 686. 2 times 343. So on that one, I just thought, well, you know what? It's even, so I'll just divide it by 2. So now I got 2 times 2 times 2. 343 is a kind of a special number too. I knew it worked with 7. So I went 7, I divided by 7, and it worked out to be 7 times 49. And I know 49 is 2 more 7s. So 343's got a bunch of 7s with it. And then now I have to make 3 groups. And if you get lazy, you can just do one bracket with the exponent 3 to represent there's 3 of them. And then I get a 2. Each bracket would get 1, 2, and 1, 7. So that's going to be 14, and there'd be 3 of them. So 14 times 14 times 14 equals 2,744. Therefore, the cube root of 2,744 is 14. Final example. Big number, 5,832. If I add those digits up, that adds to 18 again. It's crazy how often that happens with these. So I can use 9. So 9 times works out to be 648. 9 can become 3 times 3. 648. I ended up choosing 9 times 72. So if I add 6, 4, and 8, it adds to 18. So I knew I could use 9 again. So 3 times 3. The 9 becomes 3 times 3 as well. I like to cross out the numbers that I've factored further just so I know I've dealt with them. 72 can become 9 times 8. You could have went 36 times 2 as well. So now I got 3, 3, 3, 3. Now the 9 becomes 2 more 3s. And 8 we know becomes 3 2s. So I'll just write that out. I'll go back to having my 3 brackets. So I have 3 2s, so each one goes in a bracket. If I count up the 3s, I have 1, 2, 3, 4, 5, 6 of them. So each bracket can get 2 of them. And then that would break up my 6 3s. Determine the value. So 2 times 9 is 18, and there'd be 3 18s. So then the cube root ends up being 18 for this question. Here's a quick summary. Same exact steps. I've just changed a few words. So determine the prime factors of the radicand number. Organize the prime factors into 3 equal groups now. Determine the value of the equal groups. This value is the cube root of the radical. All right, I hope that made sense. If it doesn't, get talking to your teacher or come find me. Have a great night, everybody.